Okay, everyone, here we go again. We are still in Module 1. We're in Topic 1, Lesson 2. We're moving on to Activity 2, Common Factors. It says, in the getting started, you used your rectangles to determine the common factors of two numbers. Is there another way to determine common factors? Just to refresh your memory, so we had a 4 by 3 and a 4 by 4. And because we could join the sides that were 4 in length, we knew that the number 16 and the number 12 had a factor in common of 4. There is another way, and we can use something called a table of primes and find a number's prime factorization. So in the last lesson, we also did the factor trees. So we're going to work with the factor trees to determine our table of primes. So 56, if you remember, we kind of did it like this. You could have 7 times 8, that is prime. 4 times 2, the 2 is prime. And then a 2 times 2, which is prime. And then our 56 has 2, 2, 2, 3 2s, and a 7. 42 breaks down into 6 times 7. 7 is prime. 6 is 2 times 3. They're both prime. So we have 2, 3, and 7 when you put it in a table. The common factors of the two numbers are the numbers that are in both rows. You can underline that and circle the product of the numbers that are in both rows. So remember, product is when you're multiplying. So the numbers that are in both rows, in the 56 row and the 42 row, those numbers will be lined up in each column where they are shared. So they both have this 2. This has a 2, but this doesn't. Same with here. The 42 has a 3 as one of its prime factors, but the 56 does not. And they both share a 7. So the common factors are 2, 7, and 14, because if you multiply those together, you get 14. We could have broken these both down by starting with 56, and 14 times 4 gives us 56, and we could go from there. And with 42, if we had 14, 14 times 3 is 42. So there we can see that they both have 14 as one of their factors. How do you know that 14 is a common factor of 56 and 42? We know that the product of the numbers that are both in both rows. So because 14 is a product of 2 times 7, and these numbers are in both rows. Why is there a space between the 2 and the 7? So here, and that's because 3 is not a factor of 56. Only same numbers can be in each column. Okay, pause as you need. I'm going to move on. Okay, consider the numbers 54 and 84 create a table of prime factors. So over here, I'm going to do 54. All right, and maybe you just want to start with 2. Maybe you don't know two numbers that you multiply together to get 54. So how many 2's come out of 54? Well, we have 25 2's out of 50, and then 2 more out of the 4. So 25 and 2 would be 27 prime. 9 times 3. 3 is prime, circle it. 3 times 3. And then we should check it. So 2 times 3 is 6. 3 times 3 is 9. So 6 times 9, 54. And then 84. Did you know if the digits added together, a plus 4 equals 12, if the number you get when you add those together is divisible by 3, the entire number is divisible by 3? So 12 is divisible by 3, so I know the entire thing is divisible by 3. So how many groups of 3 can you get out of 84? 3 would go into the 8 2 times. Let me show you that over here. Just to review some long division by the standard algorithm. 3 times 2 is 6. Subtract, we get 24. 3 times 8 is 24. So it's going to be 84 and 28. And that is prime. 4 times 7. 7 is prime. 2 times 2. Okay, so let's check it. 7 times 3 is 21. 2 times 2 is 4. 21 times 4 does give you 84. So now we're going to create a table. And we're going to put our prime factorization in numerical order. Remember, only the same numbers can share the same column. So we have a 2, 3, 3, 3. I'm going to write that down here. 2 times 3 times 3 times 3. And for 84, we have, this is 54. For 84, we have 2 times 2 times 3 times 7. Okay, so this is going to help me just visualize how to set up my table. So 54 has a 2. The 84 has 2 2s. So I did that one. I did those. They both have a 3. Then it looks like 54 has 2 more 3s, but the 84 does not. That takes care of those. And then the 84 has a 7, but the 54 does not. Okay. So then the common factors, we have a 2 in both rows and a 3. So the common factors are those that we list from the columns and their products. So 2 times 3 is 6. Of the common factors, which is the largest? 6. Two numbers are relatively prime when the only common factor they share is 1. So sometimes you'll have numbers that when you fill out a table like this, they won't have anything in common. Those numbers are called relatively prime. That's in relation to each other. This looks like the word relative. It's an I or an L. Relative. Your relatives are in your same family and you share things with them. Numbers are relatively prime when the only factor they share is 1. Rewrite each sum using the greatest common factor and the distributive property. So if they both have 6 as a common factor, I'm going to show you that for up here. So for 54 and 84, we could do, I guess it's right here. I don't know why they skipped it here. I guess we're going to write it right down here. So if 6 is the common factor, 6 times what would give you the 54? If I cover up the 6, 2 times 3, what's left is 3 times 3, so 9, because 6 times 9 is 54, plus the 84. So I would have that 2 and that 3. Oh, you didn't even see that. Sorry about that. 2 times 3. So that leaves the 9. This 2 and this 3 are covered. It leaves a 2 and a 7. So 6 times 2 times 7, 6 times 14 gives you 84. The 56 and 42 we can take from this table that we did here. So the greatest common factor of 56 and 42 was 14. So we can write that as 14 times the quantity of. So 14 times what gives you 56? So it was these two. So the remainder would be 2 times 2. 56, or 14 times 4 gives you 56. Plus, what's left here? Just the 3. 14 times 3 gives you the 42. So that's using the distributive property and the greatest common factor. So we've factored out the biggest common factor that they share, and that is the end of the lesson. Rather, it's the end of the activity.